Hey everyone, this is lecture 9, and we're skipping over section 6.4 and jumping into 6.5, which is the average value of the function. And when you think about average value, right, when you're calculating averages, what do, right? You usually add up a number of values and divide by how many you have. So then, if we think about it on a function on an interval, right? So now we're letting those values be continuous, right? So they can be an infinite number of values, right, over this interval. But let's set it such that we're at 5 from 2 to 3. The value of the function is -2 from 3 to 4, and the value of the function is 9 from 4 to 6, okay? So how I would think about this is that, okay, well, I get 5 for 1 unit of one interval, plus -2 over another interval, plus 9 is over an interval of length 2. So we're going to have 9 times 2 and divide that by the 4 values that we get, right? Or the 4 is the length of my interval. And that's how you would kind of calculate the average value here. So if we think about extending that to infinitely many values, right, we're going to let that bottom number be our n. And really that's the length of that interval, right? So that's going to be our b minus a from, if we're talking about an interval from a to b. And the top is just the summation of all of those values, right? So the bottom becomes your b minus a, and the top becomes adding up all of the values. And adding up all of the values is just like our Riemann sum. So you get the integral from a to b of f of x dx. And that's exactly what the average value is. Okay, so the average value of a function f of x and this has to be over a closed interval, okay, is f average is 1 over b minus a, we just pull that denominator out front, times the integral from a to b of f of x dx. I'm just going to kind of put that in a box for you. Okay, so the average value is just 1 over the length of the interval times the integral of that function over the interval. So what does that look like when we go to find the average value of 1 over x on the interval from 5 to 9? So f average is just 1 over b minus a, so 9 minus 5, we have an interval of length 4, and you're integrating from 5 to 9 of 1 over x dx. That becomes 1/4. Your antiderivative here is going to be the natural log of x from 5 to 9. And so you're going to get 1/4 times the natural log of 9 minus the natural log of 5. Okay, and I would leave it like that if you're entering in WebAssign. If you want to get a decimal value, you can. But finding average values is as simple as taking 1 over b minus a times the integral from a to b of your function. Okay. Now, the one thing that we kind of is a consequence of this is that we end up with something related to the mean value theorem. So if you think about the mean value theorem from calculus, said that if f is continuous and differentiable function on a to b, it has the value f prime of c for some value in a to b such that your f prime of c is equal to f of b minus f of a all over b minus a. Okay, and of course that translated to the idea that f of b minus f of a is f prime of c times b minus a, just if I multiply both sides by b minus a. And so here, when you think about f of b minus f of a over b minus a, that's the average value of f on the interval from a to b. Okay, and so using the mean value theorem, we can prove an analogous result for the average value of f. So when we think about this in terms of integrals, the mean value theorem for integrals, it states that if f is continuous on a to b, then there exists a value c such in the interval from a to b such that our f of c equals the average value, which we know how to calculate that. That's 1 over b minus a times the integral from a to b of f of x dx. Okay, so essentially when you're finding the mean value, you can use the average value. Right? And the correlation to this, if I multiply both sides by b minus a, that tells me that the integral from a to b of f of x dx is equal to some value f of c times b minus a. Okay. And if you think about letting f of x be the antiderivative of the integral from a to x of f of t dt, and we consider the interval from a to b by the regular mean value theorem, and to be honest, I'm not going to do that, right? If we use the regular mean value theorem here, and you take the derivative of this using the fundamental theorem calculus, so it tells us that the mean value theorem, written the way we had it, this would be capital F of B minus F of A all over B minus A. And we know by the fundamental theorem of calculus that we can write this, that f of b minus f of a is the integral of a to b of little f of x dx over b minus a, right? And so that's exactly what we get using as the mean value theorem for integrals. Now, we're not going to do a whole lot with this, but I did want you to see that this is kind of a consequence of the average value. So those are related.